Okay, this lesson is going to deal with writing equations of lines from graphs. All right, we are going to use some of the information we discussed from graphing lines from first semester to help us with writing equations of lines from graphs. Now, first semester when we graph lines in slope-intercept form, standard form, point-slope form. We had a special form for horizontal lines. We had a special form for vertical lines. Now, the good news is when we write equations of lines, as long as it's a linear function, we only need one form to write the equation, and that would be point-slope form, which is y equals m times x minus x1 plus y1. So we only need two pieces of information to write the equation of a line from a graph. We need the slope or rate of change, m, and then we need any point on the line xy, which is the x1, y1 in our equation. Now, the next video will go through in detail how we can manipulate point-slope form into slope-intercept form or standard form should we need to do so. So this lesson will focus just on writing equations of lines from graphs. Now, there is one exception to writing equations of lines from graph, and that is if we have a snafu, when something's not a function. Understand? Now, we talked about this first semester in that we can determine if something is a function by the vertical line test. If it failed the vertical line test, then it was not a function. So obviously our vertical lines are not a function, so our point-slope form will not work. So we have to just remember that whenever we have a vertical line, we just have to use the form x equals a instead of point-slope form. All right, well, let's jump into some examples here and look at what we have. So now if we look at our first two examples here, they are in fact functions, which means we can use point-slope form here. So we need to find just two pieces of information: the slope of the line, all right, and any point on the line. So if you look at our first example, I've got lots of points dotted here for us, and I'm just going to take this point here, all right, which is the point 1, 9 to use in our equation. Now, like I said, you can use any point you want. All right, so we will come up with an equation here, but there are multiple versions that would be equivalent to this. So I'm going to do minus x, so that would be minus 1, and then plus y1, so then that's plus 9. Now, we talked about this first semester, so let's just review this. That slope is rise over run. Now, so to find the slope of a line, we pick any 2 points on that line. We find the ratio of the rise to the run. So if I go from 1,9 to 5,9, you can see that there is no rise, which means that is 0, but there's a run of 1, 2, 3, 4. All right, so this means our slope is in fact 0. Now if you think back to when we graphed horizontal lines in first semester, we knew that the slope would be 0 for those lines. Now 0 times that quantity is 0, which just leaves us the equation y equals 9. All right, looking at our second example here, once again, we can pick any point on this line. All right, so I'm just going to take this guy right here. All right, so 5, negative 6, and I'm going to use that for my x1, y1. So y equals x minus 5 and then minus 6. And that leaves us just the slope to find. Now, once again, I can pick any point I want, all right, to pair up with my first point. Once again, we can see that the rise is 0, and we have a run of 1, 2, 3, 4. And then once again, 0 divided by 4 is just 0. And so this simplifies to y equals negative 6. All right, so writing the equation of a horizontal line, not terrible at all. And some of you will come to recognize that the slope is 0, and you'll be able to jump right to the final answer. Now, what I'd like you to do right now is just pause the video, all right, and write the equation of these two lines quickly, and then restart the video once you've finished and compare those to the answers that I am about to write for you. All right, so you should have come up with an equation for this example of y equals 3. And for the second example here, you should have ended up with y equals 0. All right, so there's a couple of examples of our horizontal lines. Now let's look at a couple of examples that are not horizontal and do not have a slope of 0. Now once again, we may pick any point to start. All right, so I'm going to pick this point here. Let me scroll back here. There we go. All right, so I'm going to pick this point here. All right, so that is negative 5, negative 4, all right, to start our equation. Now, pay particular attention to this detail here, that this negative is part of the equation. So when I do this, I am subtracting a negative x coordinate, so that's x minus negative 5, and then I have the minus 4 out here. So what happens anytime our x coordinate of the point we choose is negative, it really ends up being x plus that coordinate if I follow my rules for multiplying two negative numbers. Now, in this case, I still need to find our rate of change. Now, once again, I can pick any other point to pair with my first point to find, all right, the slope of this line. So let's say that I picked this as my second point. Now, I need to find my rise over run. So if I look here, I come down. All right, and I go down 1, 2, 3, 4. Now, since I went down, that is a negative change, so it's negative 4. And then I have to go over 6. So my run is to the right, which means that is a positive 6. So my slope is negative 4, 6. Now, typically what we like to do before we insert this into our equation is if it's reducible, we want to do that. So if I reduce negative 4, 6, I get negative 2/3. So now I'm just going to drop that into our equation up here, and there's the equation of our line. All right, let's try our next example here. So once again, I can pick any point to start with. So I'm just going to pick this point, which is negative 1, negative 4. Once again, just to emphasize that when we do this, once again, it's x minus x1, which is negative 1, and then minus 4. All right, and then once again, if I simplify that, that just becomes x plus 1. Now, most of you will be able to jump right to this, and you won't necessarily need to write this step, but I want to emphasize that now and let you see that. Now, once again, I need to find my rate of change, all right, to finish the problem. So I'm going to look for my rise to run to the next point on our line here, and I go up 1, 2, 3, 4, 5, and I go over 2. So the slope or rate of change for this given line would be 5/2. All right, and there is our equation of a line. Okay, now let's take a look at this. All right, so here's our snafu. Something's not a function, understand? So now we need to use, all right, our special equation, all right, which for a vertical line is just x equals a. So notice every point on this line, all right, has an x coordinate of 7. Therefore, the equation is just x equals 7. Notice here that the x coordinate of every point on this line is negative 4. Therefore, our equation is x equals negative 4. So these are very simple and quick as long as we remember the form of a vertical line. All right, so let's take and practice a few more. So once again, I would like you to pause, all right, the video, and what I would like you to do, all right, is go ahead and write your equation, all right, for each of these lines, and then compare it to the answer that I'm going to post right now. All right, so for this line, all right, you should get a slope of negative 2, and then I'm going to pick this point here, which is 1, 4. All right, and so that's the form of the line I wrote. Now, whatever form you have, we should all have the same slope, so everyone should have negative 2. What might vary are the coordinates of the point that you picked. So notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 possible equations based on the point you could have picked. All right, moving on to the next example to see how you did. All right, your slope here is negative 1 over 1, 2, 3, 4. So that should be negative 1/4, and then I'm going to pick the point here, which is 2, negative 5, so x minus 2, and then plus 5. Once again, we should have the exact same slope, perhaps a different point, and you can see that there are 6 possible equivalent forms based on the points marked here. All right. Okay, so once again, go ahead and pause the video. I'd like you to write the equation of these two lines quickly, and then turn the video back on and compare them to these two equations. The first would be x equals 0, all right, and the second one being x equals negative 10. All right, so hopefully you're starting to see some patterns to this. You're starting to pick up on, all right, what you need to do. All right, so a couple more examples here. All right, so once again, go ahead and pause the video, attempt these two, all right, on your own and then compare them to the work that I'm about to do. So for our first problem, all right, our slope is 1. And then the point I'm going to pick this time is 0, 0, which is the origin. So x minus 0 plus 0. And notice that if I were to simplify this, this would just give me y equals x. Pretty quick, pretty straightforward. Okay, for our next equation here, okay, we should have all come up with a slope of 2 over 3 up 2 over 3. And then I'm going to take the point here, negative 2, negative 3. And then once again, since I'm subtracting a negative, it's going to become a plus 2. And then I have my minus 3 out here. All right. And then a couple more examples here. So once again, pause the video and give it a shot. And I'll post the answers right now. All right, so for this one, we should have a slope of negative 2 over 7. And then I'm going to use the point here, which is 7, negative 2. So x minus 7, and then plus, excuse me. All right, so let me erase that. It should be a minus 2 there. All right, there we go. And then on our example here, the slope is negative 1. And then I'm going to use this point here, which is 0, 10. So x minus 0, and then plus 10. And so we end up with negative x plus 10 for your final answer. All right. So what that means now is that you should be able to come into class tomorrow and hopefully have any questions you have remaining over the examples or this lesson ready to go. And then hopefully we can jump right into worksheet unit 4.1. Now the second video is called Manipulating Equations. So you should watch that as well because there will be a few equations that you have to manipulate into slope-intercept form or standard form as well on the homework sheet. So please take a look at that video and then bring your questions and be ready to work in class tomorrow.